In this presentation, we'll go over some best practices for working with entities within the entity extraction node. We'll start with some tips and tricks for making the most out of the default standard entities we have in our entity extraction node by building out our own custom entities around them. So here's an example of some text where we've extracted a variety of standard entities, things like people names, organizations, locations, addresses, dates, and times. Now, the standard entities that are pre-built into PolyAnalyst are typically sufficient for most business needs. But of course, they can also be a good starting place to add some other business meaning. Suppose you have something simple like a date, but you want to attach some other information to it. For example, you might want to distinguish it as a date of a car accident versus it being a birth date of someone involved, or the dates that someone's insurance is valid. And in this record here, we see a couple locations that were automatically identified and extracted as locations. In this case, Fort Worth, Texas, and Washington, D.C. Now again, this location information in its current form might be sufficient enough. However, if you look at the bolded text around the entities for additional context, we can see that these are actually specific types of locations that might matter to our business needs. So we see for the first extraction, it's actually the location of a company. And for the second, it's the location where some work will be completed. Now, as human readers, we're able to make these sorts of distinctions pretty quickly if we're able to manually read through every document. But that's the catch. It takes a human quite a bit of time to read through the documents like this. And as we receive more and more documents, it becomes harder and harder to keep up on these tasks. So that's why it's important to automate this type of process. So we just need to take these default location entities and add more context around them using XPDL, and then convert them into a custom entity for location. So let's take a look at how to get started doing this. First, you'll need to have executed an entity extraction node that extracts all your default entities. And then you connect a second entity extraction node to this. And this is the easiest way to begin customizing entities towards your specific business needs. Now, how exactly do we use the default entities in this custom entity extraction node? Well, the answer is you'll need to use the entity function. So the entity function allows you to use the rich information that you already extracted with the default entities. So for example, with the locations entity, you would call it like this. And by using this function, we'd be able to access the following results from the location entity we extracted earlier. Notice that there's much more than the verbatim text in the record. It actually automatically breaks down the location name into useful attributes such as city, state, country, and so on. Of course, you can do this with any of PolyAnalyst's default entities, such as people, contact information, company names, and so on, and the relevant attributes will be automatically broken down in a similar manner. So if we think about how we can customize a default entity in an XPDL expression, we'd essentially be calling the entity of our choosing with the entity function and any extra context that adds business meaning around the entity. So in the examples we saw earlier, a company location would be comprised of the location entity and a company entity. And a work location would be made up of the location entity and some phrase or keywords to the effect of work will be performed at. Now to do this, we add the attribute location in an attribute block. And let's return it to a column called work location, since this will produce a list of all our work locations in our data set. So our results in the end would look like this. So the result column gives us everything that we queried, and the work location column shows only the city. And if we want to just return the city, we can do that too. We just need to return the location attribute in the result block. Now, notice that we can't just type location into this result. This is because location is an attribute or a subgroup of the group context. So we need to tell the machine the path it needs to use so that it can access the location subset. Now we do this by specifying the main named group, a colon, and the subgroup that we want to return. Once we've done that, the result block will only return the subset location into the results. So now we can open up our record and see that Washington, D.C. is a custom work location entity now. And if we want to make Fort Worth, Texas a company location, we can use the same ideas, but we'll need to change the additional context. So in this case, the additional context we'd need is a company entity, which we'd find near the location entity. And then in the result block, we can return the company names and locations that fit this pattern. And if we look at the results, we have a column for each of these, and the results are automatically populated with the matches from our named groups. So now when we go back to our record, our results are more customized to our business needs. And if we apply our simple XPDL rules onto a larger data set, we're able to automatically find even more company locations and work locations. However, it looks like we're just returning the verbatim location from the records here. And that could work well enough for most business needs, but it might be nice to return all of the structured information from the entities, such as the columns for city, state, and country. So this is where the toEntity function comes in handy. Now, remember when we called the entity function and it gave us all this information? Well, in reality, the entity function won't return all this information by default. So in this example here, when we use the entity function, the default is to just return the verbatim text for the locations. Or in other words, it's returning the name column from our entity dataset. And if we compare that with our results from the last rule, we'll see they're identical. Now, to return any of the other columns in this dataset as attributes, we'll need a special output function for our result block. And that output function is called toEntity. So the toEntity function is used to call pre-existing entity attributes. It's used exclusively in the result block of an XPDL rule. And it allows you to specify the exact attribute or column that you'd like to place into your structured data set. So to use the toEntity function, just specify the entity's name, such as locations. Then you state which named group in your query contains that entity. This is essentially a list of the entities that meet your specific criteria of work or company locations. And finally, you specify the exact field that you'd like to be returned to your dataset. So this refers to the column names in your default entity. Now, let's take a look at how to use this function with our previous example. Now remember that the name column is the default column that would be returned here, because it just returns the verbatim from your record. So you don't need the toEntity function to return that one. So for that, you just type your named group as you normally would to get the verbatim text from your record. However, if you wanted to return the city as an attribute, you'd need to use the toEntity function because you're accessing another part of the data structure. So you'll need to specify exactly where in the data structure to find it and for which contexts. So we specify the entity we found, what named group we stored it in, and which field we'd like to return. And if we check the results, we can see that it would return just the city name. Now you can also return the region column by just changing the field parameter to the region column. And if we look at the results, they've updated to just return that column. And lastly, you can do the same to return the country attribute by just updating the field again. And the results would update just like before. So if you wanted to return the entire dataset for locations, you can structure your results block accordingly. So notice how there's a new attribute for each column here, just like its original entity. Now remember when we talked earlier about the entity function and how it only returns this simple result? So in some cases, that might be fine for our needs, but if we wanted to return something with more information, perhaps something that's more sophisticated like this, we have to use the toEntity function in our result block. And now we have a data set of not only the verbatim from the record, but also the city and the state attributes. Now let's move on to some hands-on practice. In this hands-on practice, we'll go over how to build custom entities around our standard entities, and how to use the entity and toEntity functions to customize our XPDL output. Now, the data we'll be working with here is a series of example insurance claim records, and our goal is to extract whether a name in the record is the claimant or the insured party. Now, we see a convenient pattern in these records for extracting this information. We see that the word claimant or insured is followed by a colon, and then the name associated with the title is listed. So we can use this information to build our custom entity for party. Now, before we build these custom entities, we first need to run the entity extraction node to extract standard entities like people names, which we've already done here. And if we open this node, we see that the system found 7 people name entities in our dataset. And we also see that the entities are stored with the first names, last names, genders, and other attributes. Okay, now we're ready to create our custom entities. Let's go into this other entity extraction node that we've connected to the first one. So in here, we see 2 custom entities set up. Right now, these entities have the same expression, and they only match instances of the word insured that appear in the text records. And now this query specifically looks for any terms for insured that we've specified in our dictionary. And if we switch over to our word class dictionary that's specific to insurance, we see that there's a list of terms for insured that PolyAnalyst will look for when identifying the insured party versus the claimant. Now, for the rest of this rule right now, it'll return the verbatim match that was found in the records, which we can see if we click over to the Results tab here. So the goal is to expand this rule and output additional information related to the match in our results. And we can do this by expanding our rule here and using the entity function. So let's switch to a version where we've already done this. So now we see the expanded rule here. This rule will still find instances of the term insured in the records, but then it'll look for the special pattern we noticed in the records, where we have the term insured that's near a people entity, which we specify by calling the entity function here. Our results will then be returned as the match, with the following additional attributes we specified. So in this case, we want to return the party attribute as insured, and we want to return the name of the person as well. And when we click over to the results, we see the 3 columns we specified for these entities. Now, you'll notice that the entity function only lets us return the full name that was captured by the people entity. If we want to return other attributes associated with that people entity, we need to use the toEntity function. Now, this is what we get when we use the toEntity function. We see the first and last names are returned in their own separate columns. So let's switch back to the properties and see how this rule is different than the one for the first entity. Okay, so our main difference is that the rule now uses the toEntity function in the results block here. So we still have the results return the match column and the party column, but instead of just returning the full name, we now have it return the first, middle, and last name that were already extracted by the people entity. And this concludes our topic on XPDL best practices. Up next, we'll go over how to perform data redaction tasks using the entity anonymization node in PolyAnalyst.